After arithmetic progressions, now we have geometric progressions. Consider the following sequences: 2, 4, 8, 16. So if we observe this pattern, we are multiplying each time by 2. So 8 times 2 is 16. Next term will be 16 times 2, which is 32. Next term, 32 times 2, which is 64. Now part B. 2 minus 6, 18 minus 54. Here, each term is minus 3 times the preceding term. So here, 2 times minus 3 is minus 6. Minus 6 times minus 3 is 18. 18 times minus 3 is minus 54. And minus 54 times minus 3, we obtain 162. And 162 times minus 3, we obtain the next term, which is minus 486. Part C. 1,500, 250. So here it is obvious that we are dividing each term by 2. So 1,000 divided by 2, we obtain 500. 500 divided by 2, we obtain 250. So instead of saying divided by 2, we can say multiply by half. So these two are the same. Here we use multiplication. We say 1000 multiplied by half is 500. 500 multiplied by half is 250. Here 250 multiplied by half, which is 125. And next term is 125 times half, which is 62.5. And the last part, 1 over x, 1 over x squared, 1 over x cubed. So here it is clear that we are multiplying by 1 over x. 1 over x, so the next term will be 1 over x power 4. And here 1 over x power 5. So these sequences are called geometric progressions. We can see that in these sequences there is a constant multiplier. For example, here the constant multiplier is 2. Here it is minus 3. Here it is half. And here it is 1 over x. And this constant multiplier is called the common ratio. And the common ratio is denoted by the letter R. And just as for arithmetic progressions, we denote the first term by A. First term A. So a geometric progression is a sequence whereby each term is preceded by a constant multiplying factor. We can also see that the common ratio R can be both positive and negative. Now let's consider the terms of a geometric progression with first term A and common ratio R. So the first term, which can be written as U1 is equal to A. The second term u2 is equal to, so if we have first term a and the common ratio is just like here, if the common ratio is 2, the next term is 2 times 2, we get 4. Here, if the common ratio is minus 3, so the next term will be 2 times minus 3, which is minus 6. So here the common ratio is r. This means that the second term will be a times r, which is ar. So the second term is ar. Third term. To obtain the third term, we have to multiply the second term by r. So we obtain ar square. Fourth term, u4 will be ar square times r, which is ar cube. So we can observe that for the first term, u1 is a. Second term, when we have u2, the power here it is 1. When we have 3, here u3, the power of r is 2. It is 1 less. When we have 4 here, the power of r is 3. So again, it is 1 less. So we can say that the fifth term will be ar power 4. 5 here, then we have 4 in the power. So if we go on like this, we can say that the 10th term, u10, will be ar power 9. 10, here 9. So if we have the 25th term written as u25, we can write it as ar power 24. So if we continue like this, we can have our nth term written as un. It will become ar power n minus 1. Here we have n minus 1 here. So this is the nth term of a geometric progression with first term a and common ratio r. So the nth term of a geometric progression is given by un is equal to ar power n minus 1. To calculate any term of a geometric progression, we just need the first term a and the common ratio r. And the common ratio r can be easily obtained by taking un divided by the preceding term, that is un minus 1. For example, we can take the second term and then divide by the first term, or we can take the third term divided by second term. So here it is second term over first term, here third term over second term. Let's have a look at the first example. Write down the 8th term and an expression for the nth term of the following. First part, 5, 10, 20. So clearly this is a geometric progression with first term 5 and common ratio. We can take 10 divided by 5, the first term, we obtain 2. So the 8th term, denoted as u8, if we apply the formula, it will become ar power 7. So we have 8 here. In the power, we must have 7. So 5 times 2 power 7. So it is 5 times 128, which is 640. So here we must be cautious. Only 2 has power 7. So we cannot multiply 5 times 2, obtain 10, and then take power 7. This is wrong. If we take 5 times 2, 10, and then we take 10 power 7. This is wrong. And also we have to find an expression for the nth term. Nth term, that is un, is equal to ar power n minus 1. So a 5 or 2 power n minus 1. We leave it as such. The second one, we have half, 1/4, 1/8. So again, this is a geometric progression with first term half and common ratio half. 1/4 divided by half. We obtain half. So the eighth term, u8, is equal to ar power 7, that is half times half power 7, which is half over 1/128. We obtain 1/256. This is for the eighth term. And for the nth term, un, it is ar power n minus 1, which is half power n minus 1, and we leave it as such. Now we have a second example. The second and fifth terms in a geometric progressions are 12 and 40.5 respectively. Find the first term and the common ratio. So the second term, which is u2, ar, is equal to 12. This is equation 1. And then the fifth term, which is u5, which we can write as ar power 4. This is 40.5. So this is equation 2. We have to find the first term and the common ratio. So here we can take the second equation and divide by the first one. This gives ar power 4 over ar. And here we have 40.5 over 12. When doing so, the a cancel out and we remain with r cube 40.5 divided by 12. So this is 27 over 8. And we take cube root of 27 over 8. We obtain the common ratio r as 3 over 2. Next, we substitute r by 3 over 2 into equation 1. We obtain a as, so we have a times r, 3 over 2 is equal to 12. We obtain a as 12 divided by 3 over 2, which is, this gives us 8. So the first term is 8 and the common ratio is 3 over 2.